Hey guys, this video is about some index rules, timesing and dividing. There's some special properties with multiplying and dividing indices with the same base number. That lets you get to a shortcut to the answer without having to find the answer to a really long, power, like 2 to the power of 17. You don't want to spend your time working out what the answer to that is when you can just use a shortcut. So same base numbers with different powers, or that can even be the same powers. Whereas for multiplication, the answer for the same base numbers being times together with different powers is just to add the two powers together and put that on top of the same base number. So multiplication, add the powers. So how can I show this rule? I'll show it with an example. 2 to the power of 6. What is that in factor form? 2 times by 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 2. So that is 2, 4, 8, 16, 32, 64. The answer to that is 64. And let's say 2 to the power of 3. What is that? 2 times by 2 times by 2, which is 2 times 2, 4 times 2, 8. So what we've got here is 64 and 8. What do you notice about 64 and 64 times by 8? What is that going to be? Well, let's get the calculator. 64 times by 8 is going to be 512. Now if you notice here, what we have done is just done a simple way of writing 2 to the power of 6, and we've times it by 2 to the power of 3. Now what is 512 as a power of 2? Well, if we've got 64, which is 2 to the power of 6, 64 times by 2 times by 2 times by 2, 2 times 2, that's 6. We know that's 64. 64 times 2, 128. 128 times 2 is 256. 128 times 256 times 2 is 512. So 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7 is 128. The power of 8 is 256. To the power of 9 is 256. So 2 to the power of 9 is that, equals 512. So we have gotten to this point now, because 512 is the same as 2 to the power of 9. And what do you notice here? 2 to the power of 6. Try and get my laser pointer. 2 to the power of 6 times by 2 to the power of 3 is 2 to the power of 9. What has happened between those two powers? These have been added together. Now I could go all the way through and prove to you with 2 to the power of 17 times by 2 to the power of 52. It doesn't matter. As long as the numbers have as long as the powers have the same base number, and you notice that they're timesing together, all you have to do to find the answer is write the same base number again and add the powers. So with this rule, if you had something like 2 to the power of 17 times by 2 to the power of 23, you don't need to spend all your time doing something like this and work out what 2 to the power of 17 is. You can notice that there's 2 the same base number and they're being times together, so the answer is going to be that same base number with 17 and 23 added together. So 17 plus 23, 23, 30, 40. The answer is going to be 2 to the power of 40. And heck, if you're interested, try it on your calculator, times whatever the answer to 2 to the power of 17 is with whatever the answer to 2 to the power of 23 is, and you'll find that the answer is the same as 2 to the power of 40. So you get a little shortcut there. You have a little index rule that if you say the same base number with different powers, or even the same powers being multiplied together, all you need to do is add the powers and put it on the same on the top of the same base number. So that's for multiplication. If I switch over to division, so I'll move down, and we'll use 2 to the power of 6, 2 to the power of 3 again. Division is very similar, it's just the opposite though. Instead of adding the powers together, you subtract them from each other. So we said, I'll tell you the rule now, subtract the second power from the first, and you'll get your answer with the same base number. So we have 2 to the power of 6 is 64, and 2 to the power of 3 is 8. Now what is 64 divided by 8? Well, if you're good with your times table, you should know that it is 8. And how would we write this with powers? Well, 64 is 2 to the power of 6 divided by 8 is 2 to the power of 3, and then we said the answer was 8. What did we say 8 was again as a power? Well, it's 2 to the power of 3 again. So what has happened between this 6 and this 3? It's been subtracted. So that is the rule. It's just the opposite of timesing the powers together. It's dividing this time, and instead of adding the powers together onto the same base number to get the answer, you just take them away. So if you had something like 2 to the power of 50 divided by 2 to the power of 25, you don't need to work out what 2 to the power of 50 is, or all the way through. You don't need to work out what 2 to the power of 25 is. You just notice that these are the same base numbers and they're being divided. They're being divided here, so the answer is going to be the same base number with the powers subtracted. So 50 take 25 is going to be 2 to the power of, it's going to be 2 to the power of 25, whether you like it or not. You can prove that using the calculator again. I won't take the time to write it all out because that's just a proof. And so hopefully that helps you with the rest of those indices sheets, and see you in the next one.